So we just go to the CropARM website, which is free, just through the Queensland Government. Go for CropARM, the third one down. And we've got 3 steps: sites, crops and scenarios. So the first one is to go to sites. Obviously we can choose any state in the country, but we'll go for Tassie. Let's pick Cambridge for starters. Note that you can only pick one site. Apply. Go to crops, we can only pick wheat. Hit apply. Then we go to scenarios. Now this is where you can answer all sorts of what if questions. So we've got all of these management options, and these change according to the site. Technically you could select all of these boxes and display all of them side by side to see what the relative differences are, but that would be too cumbersome and very difficult to understand. So I'm just going to show you how I would use this decision support tool to make decisions, if you like, between different management scenarios and to determine, for example, which grain yield might be best over the long term. So here I'm just going to contrast Mackellar with Tennant. So I check both boxes, hit apply, and it's just a simple box plot. So each box plot displays 100 different grain years. So here I'm showing dry grain yield in tonnes per hectare. The median long-term grain yield, which is the 50%, is 1.62 tonne, and if you mouse over you can see that data coming up there, and that's for Mackellar. And for Tennant we've got a medium grain yield of about 2.5 tonne, which is much higher. So intuitively I would select Tennant for that site in this scenario anyway. So we can go back to scenarios. We've established that Tennant's the best, so uncheck Mackellar. Now let's contrast plant density. So we've got all sorts of plant densities ranging from 60 to 250 plants per square metre, but let's just contrast the two most extreme ones, so 60 versus 250. Hit apply, and there's not a lot of difference, but plant density at 250 plants per square metre at emergence anyway is generally higher over the long term, although there is some overlap in the distributions of the two. So I would probably go for 250 plants per square metre. Go back to scenarios again, take off the 60. Now let's just contrast sowing dates. Let's say 15th of April versus 15th of June. And so we can see that in the long term, 15th of April results in a much higher grain yield compared with sowing later in 15th of July. And obviously there might be other optimums of different sowing dates in between, but I'm not going to investigate that here. Go back to scenarios again. Take off 15th of July. Let's put 100 nitrogen on at sowing and contrast dry land with heavy irrigation, which is irrigating to soil water deficit whenever soil water deficit gets more than 10 millimetres between Zadok stage 35 and 65, sorry. So what this is doing is it's showing us that irrigation has taken out the large proportion of low yields. So in years where the crops would be normally soil water limited, you get all these low grain yields from 3.5 up to about 5 tonne. Irrigation's taking out those years, so you can see you're getting a much smaller distribution of grain yield, and it's probably approaching its potential grain yield there. And so just as an aside, we can do all sorts of different outputs in CropARM. So we can do, I've got box plots there, but we can do bar charts, and it shows you different bar charts as a time series, and you can go back to particular years which were particularly low, for example 2006, but irrigation in that year brought grain yield up to the long-term average grain yield, so it's heavy irrigation, sorry. Cumulative distribution functions. The way I read these, as I indicated in the presentation, is that if you look at the 50th percentile, you can see that in 50% of the time the dry land irrigation is going to get about 5 tonne, compared with 50% of the time the heavy irrigation is going to be about 5.6 tonne per hectare. And there's other sorts of graphs. You can also look at other variables in the output. So perhaps one that might be useful to look at in this case would be irrigation water applied. So obviously the dry land one is 0, and this is the long-term irrigation water applied for the heavy scenario. So if we just go back there, put another irrigation on, light irrigation, hit apply, we can see that light irrigation 50% of the time is applying about 125 millimetres over the growing season, whereas The heavy irrigation strategy is applying about 270 millimetres.